All right, you are welcome once again. And in the previous video, we saw the solutions to question 4. In this video, we will be solving question 5. All right, stay tuned. Don't go away. All right, you are welcome to the solution of question 5. In question 5, we have this diagram. And on that diagram, we have the graphs of f of x equals log x space a and g are drawn. Graph G is a reflection of f in the line y equals x. Graph F passes through the point P with a coordinate of 4, 2. Q is the x-intercept of F, and R is the y-intercept of G. The first question is to write down the coordinate of P prime, the image of P on G. So if we look at this graph, if we look at the graph of F and G, we have been told here that G is a reflection of F in the line y equals x. So it means that if we are looking for P prime, which is the image of P on G, all we have to do is to swap the coordinate of x and y. So here it means that the coordinate of P prime, the image of P on G, would be 2, 4. So the x coordinate will be 2 and the y coordinate would be 4. Question 5.2. Show that A equals 2. Now, we know that f of x equals log x base A. So if we look at that, all we need to do is to locate a point on F that has both x and y coordinate. And here we have point P, which lies on F. All we need to do is to substitute the value of x and y into this equation. So in place of f of s, which is y, you put 2, and in place of x, you put 4. So we can solve for A. Let's rearrange that equation. So if 2 equals log 4 base A, it means log 4 base A equals 2. Now, let's make A the subject. To make A the subject is very simple. All we have to do, if you look at the left-hand side, the base of this logarithm is A. Now, to get rid of this logarithm, you will have to take A to the other side. But by the time A gets to the other side, it will also be a base, but this time around, it will be the base of an exponent instead of a log, right, on the other side. So we have 4 equals A exponent 2. Now we can rewrite 4 in its exponent form, which is 2 exponent 2 equals A squared. If we look at the two exponents, they are equal to each other. So we can cancel the exponent and we are left with the base, which means that A will be equal to 2. Now we can rewrite f of x. Since f of x equals log x base A, we can substitute A into the function. So it means that f of x equals log x base 2. That is the solution to question 5.2. Next is question 5.3. In 5.3, they said we should write down the equation of G in the form y equals 2. If we look at that G, since G is a reflection of F, it means that G will be the inverse function of F. So you know how to do the inverse function to to calculate the inverse of a function or to derive the inverse of a function, you need to switch the position of x and y. So it means that we have to put x here. You know, y was here originally for f of x, y was here and x was here. So to derive the inverse function, you will have to put x in place of y and y in place of x, and you would make y the subject of the formula. You will solve for y. So let's see how that plays out. So it would mean that log y base 2 equals x. We are just switching this around. Remember what we did in the previous question. To deal with this log, you will have to take this base to the other side. By the time the base gets to the other side, to the right-hand side, it's also a base there, but it will be a base of an exponent. So let's see how that pans out. So it will be y, you retain the variable here, you take the 2 to the other side, it retains its status as a base, and the number you have here becomes an exponent. So the inverse function, which is g of x, will be y equals to exponent x. It's 5.4. And in 5.4, they say that t is a point on Earth in the first quadrant. In the first quadrant, where TR is parallel to the x-axis. Calculate the area of triangle RTP prime. They said that TR is parallel to the x-axis. So if TR or RT is parallel to the x-axis, and they said that that point T lies on F, it means that the y coordinate at T would be equal to the y coordinate at R, since the line is parallel. So it means that this line RT is perfectly horizontal. So it's parallel to the x-axis. So the y coordinate at T would be 1. Now, if the y coordinate at T is 1, then we can calculate the coordinate of x at T. All right. So all we need to do is to write the function f of x, which is what we have on the board here. And so we have to look for the coordinate of x at T, which attain Tx. Yeah. So what we do is substitute y equals 1. So in place of f of x, you put 1, and that will be equal to log x base 2, and we make s the subject. So I've already taught you how to do this, how to deal with this logarithm. So in that case, x will be equal to 2 exponent 1, which means that x will be equal to 2. So it means that the coordinate of x at this point T is 2. Now, the question they ask us is to calculate the area of triangle RTP prime. RTP prime. So one other thing you need to note here is that if the coordinate of x at T is 2, it means that T and P prime would share the same x coordinate. So if T and P prime have the same x coordinate, it means that this line TP prime would be a perfectly vertical line. So it means that the line TP prime would be parallel to the y-axis. So that is very important to know. And you know that this Tx, the coordinate of x at T, is 2, right? So now we need to calculate. Remember the formula for the calculation of triangle. And before we get there, if you look at this triangle, if you look at this triangle RTP prime, since line TP prime is perfectly vertical and line RT is perfectly vertical, it means the lines are perpendicular to each other. Therefore, this angle here would be 90 degrees. It means we are dealing with right-angled triangle. And if you are dealing with right-angled triangle, to calculate the area is simple. The formula will be half base times perpendicular height. The perpendicular height in this case will be TP prime, and the base will be RT. So we can substitute that into the formula and we get the area of this triangle. Now, how do we get TP prime, the length here? It's very simple. You just have to compare the y coordinate. The y coordinate here is 4 and the y coordinate here is 1. So the distance here will be 3 units, 4 minus 1, right? Here, the distance RT would be the value of x at this point, which is 2, minus the value of x at this point, which is 0. So it will be 2 minus 0. That means the length of RT would be 2. Also, you can use the distance formula, but that's a waste of time in this case. You don't need to stress yourself. You only need to use that distance formula if you are dealing with lines that are not perfectly vertical or perfectly horizontal. For example, if you want to calculate the length of RP prime, then you have to use the distance formula. But since you are dealing with perfectly vertical line here and perfectly horizontal line, then you don't need to use the distance formula. You can just calculate it directly. So let's substitute. So RT equals 2 units. That is 2 minus 0. Then, so the distance TP prime, the distance here will simply be 4 minus 1, which is 3. So I've already explained this. Now, area of triangle RTP prime equals this. Since you are dealing with a right-angled triangle, therefore, the area will be half multiplied by the base RT, which is 2, then multiplied by the perpendicular height 3. 2 cancels 2, you are left with 1 times 3, which is 3. So it means the area of this triangle RTP prime will be equal to 3 units squared, or 3 squared units. And that is the end of question 5. All right, thank you for staying with us to the end of question 5. Next, we will be solving question 6.